let's say I had 14 people in a room, and these are their heights in inches. And I wanted to find what is the average height of the people in the room. Well, what I would do is I would add this all up, and I would get 952. And then I would divide that by the 14 units that are here. And I'd say we have an average height of 68 inches. I planned it that way, just so you know. So let's just kind of put that in here. 68. And we're going to call that X bar. That is our mean. Okay, that is the mean of height of people in the room. Now, what I'd like to find out is the average distance the group is away from the mean. So on average, how far are the people away from the mean? Well, let's just take an example here. And let's look at the person who is 70 inches. Okay, so 70 inches is minus 68, which is the mean. They are 2 inches away from the mean. So let's write that right here. This is 2 inches. Oh, and we have several 70s. I think I made a mistake. No, I just checked. I didn't make a mistake. So 2 inches, we have several 70s. So they're all 2 inches away from the mean. 69 would be 69 minus 68. That's only 1 inch from the mean. Now, 67 is also 1 inch from the mean. And for right now, for purposes of this explanation, we're going to leave it as a positive number because that's how far away it is from the mean. You know, it's kind of like the absolute value. And 66 is also 2 inches from the mean. So on average, I would add up these numbers here that are away from the mean. So I have 2 times 3, these right here, plus 1 times 4, these right here, plus another 1 times 4, these right here, plus another 2 times 3. So that's 6 plus 4 plus 4 plus 6. So that is that's equal to 20. So 20 inches away from the mean is the total of all of these, but I have 14 units. So I divide it by 14 and I get 20 divided by 14. So on average, each person is let's call it 1.43 away from the mean, 1.43 inches away from the mean. Now, I would write that using mathematical symbols as saying, well, for each data point, x, I took that data point, I subtracted the mean, I added all of those up. This symbol right here is sigma, the Greek letter sigma, and that stands for sum. I summed them all up, and then I divided by the number of units, n, let's just identify that, n is the number of units. So that would be one way of finding the mean. Actually, if we did it that way, we would be looking at the absolute value of each of these. And the reason we had to do the absolute value in our initial pass at this is that in reality, each of these that are below 68 are negative numbers. Negative, 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 negative. So I would have had 2 times 3 plus 1 times 4 plus negative 1 times 4 and negative 2 times 3. Well, that would have given me positive 10 plus negative 10. Well, that would have given me 0. And that really wouldn't help us at all. And that stands to reason, because since the mean is right in the middle, if I added up everything below it and everything above it, well, they would all cancel each other out. That's part of what it means to be the mean. So what we do in statistics is, instead of taking the absolute value, what we do is we take this x minus x bar, the data point minus the mean, and we square it, because that takes our negative numbers and makes them positive numbers. And then we add them all up, but since we've squared it and kind of, let's say, artificially magnified the differences between each data point, what we do is we take the square root of this whole thing to try and bring it back down to a regular number, not a squared number. So we take each of our differences between each data point and the mean, we square that number, then we add them all up, and we divide by the number of units. And that gives us kind of like an average distance that each unit is away from the mean. Now I'm going to just throw a monkey wrench in here, a tiny monkey wrench, and we don't actually divide it by n, we divide it by n minus 1. Now, why do we do n minus 1? I honestly can't explain it to you in a simple fashion. So I don't see that much difference between n as the number of units and n minus 1 is the number of units, especially when we're dealing with a whole bunch of units, which we generally are. So I'm advising you to just accept the fact that we use n minus 1. So this formula right here that I just did, taking each data item, subtracting the mean, so I'm finding out for each data item how far it is away from the mean, squaring it to get the all the numbers being positive, then adding each one of those together, dividing by n minus 1, and then taking the square root of that whole thing, that is the standard deviation. And that is a measurement deviation. That is a measurement of how far away a particular data item, well, how far away the data items are on average from the mean. Now, I know calling it on average isn't like 100% technically correct, but I think it's a good way to think of it. Now,